In this video, I want to continue our discussion about process capability and the metrics CP and CPK. The specific learning objectives will be to use collected historical data and to use Microsoft Excel and QI macros to calculate CP and CPK, and then interpret the results of the calculations. So I've got performance data. This is 7 different groups from a past class that shot toy catapults, and we collected the distance data. In the case itself, the catapults were set up to, the challenge was to shoot a catapult ball and have it land between 105 and 95 inches. So the spec limit was 95 to 105. They did this a number of times and then recorded their results, and now we're going to analyze those results. Let's take a look first at team HFI. And so I'm going to highlight their data in Excel. I've got 30 data points that they shot, and let's do a histogram with CP, CPK statistics. So I'll go up to QI macros, go to the histogram and capability section, choose histogram with CP, CPK, subgroup size of 1. The upper spec is 105. And the lower spec is 95. We got this information just from the case, the way it was set up. Those were the needs of the customer. And I'm just going to use the default value for number of bars. And there's a histogram showing the results. Here's a couple of things that I can see right away. When we take a look at the spec limits in red, upper and lower and upper specification limit, this histogram curve falls just about in the middle, pretty close to nominal dead center target. So right away, I'm thinking whatever the CP and CPK values are, they're probably going to be pretty close to each other. And I refer you to earlier videos on understanding CP and CPK for the reasoning why. But in a nutshell, CPK considers not just the width of the process compared to the width of the specification, but how close to the nominal dead center target are you? And if we zoom in here, one of the ways that this is validated, oh, which by the way, hey, look, CP and CPK, they're darn near identical. Actually, they are identical. And part of the way that we can tell this is that, the mean is right in the middle of the spec limit. If spec is 95 to 105, the mean is right there at 100. It makes sense. It is darn near centered. It also makes sense that the CP value is probably less than 1 because it doesn't look like we've got, let me zoom out here. It doesn't look like we've got a full 3 standard deviations that fall within our spec limits. It's a fairly, I don't want to call it a fairly fat curve, but it's a fat curve by CP/CPK standards. So it makes a little bit of sense that the CPK is a lower value like that, 0.54. Okay, let's take a look at another team's output. I'm going to take a look at team Melt next. I'm going to highlight their data in Excel. I am going to go up to the QI macros menu, choose histogram with CP, CPK, subgroup size of 1, upper spec of 105, lower spec of 95, and choose the default number of bars. And this group as well, very nominal dead center. Their mean is right at 100 as well. But if you take a look at the amount of standard deviation and just take a look at the histogram output curve, it's a much skinnier curve. So I would expect to see CP and CPK values that were equal or pretty close because you're pretty close to the nominal dead center target. And I would also expect those CP and CPK values to be much higher than what we saw before. And if you zoom in, your CP and CPK values are pretty close to each other, and they are much higher indeed than what we saw before. Yeah, so what this tells me is there's still, based upon this very little amount of variation, there's still some opportunity at further centering. to get this right at 100, for instance, with this little variation. That's why we see a little bit of difference between CP and CPK. And the numbers are quite high. And with CP equal to 2, I'd expect our sigma level of performance to be right around 6, and that's exactly what we've got. Let's take a look at another team's data next. So, all right, I'm going to take a look at the Bloom's data set next. So let's highlight this group's data. We'll go into QI macros, choose histogram with CP, CPK, subgroup size of 1, 105, and 95. And here's the output curve. Okay, so before I even zoom in, take a closer look at the numbers. Here's what I see. Fairly fat curve. A lot of shots that also are on kind of the low end of the average. And definitely that average is not in the nominal dead center target. So before I even look closely at what the actual values are, I could say that whatever CP is probably going to be higher than CPK because we've got a bit of a centering issue here. And the fact that this is a really fat curve, I'd expect to see CPK values that are less than 1. And let's take a look more closely at what we've got. And sure enough, the average is 96. That means it's off. We'd want it to be closer to 100. As a result, CP and CPK, those values have some separation, some difference between the two. And the numbers, CP and CPK values, are pretty low given the fact that we've got so much of this process curve that's hanging outside of the spec limit. If we were going to improve this system, we'd want to shift the mean closer to 100, and we would want to skinny the process, reduce some variation. One of the great things about CP and CPK is its ability to help you better understand, is this a shifting of central tendency issue, or is this a skinnying or reduction of variation issue, or is it a little bit of both, like we see in the last team's case data? All right, that about wraps it up. I hope the demo helped, and I'll provide you with some other case data for you to work on and explore next.